course video for physical chemistry, and that is the first part of our thermodynamics crash course. So thermodynamics 1, here we will discuss the basic concepts in thermodynamics, first law of thermodynamics, and thermochemistry. Okay? Guys, o di ba? Ang galing. Ginamit natin, kaya natin gamitin ang thermodynamics para palamagin ang tea. Kaya whoever said that di nagagamit in real life ang thermodynamics, mali yan. Siyempre, thermodynamics is everywhere. So what is thermodynamics? Thermodynamics studies the flow of energy in any form into or out of a system while it undergoes a physical or chemical change. Ayan. So it is concerned with the measurement of the initial and final state of a system as it goes through various transformations. So the term thermodynamics is made up of two words, thermo, which means heat, and dynamics, which means movement. So thermodynamics explains the movement of matter and heat. Okay. Now, first we will discuss the basic concepts of thermodynamics, starting with the open and closed isolated system, state of a system, zeroth law, and the thermodynamic process. So, syempre, establish muna natin, guys, yung mga basic concepts, okay? Para hindi tayo mahirapan in reviewing thermodynamics. So, first, for us to understand thermodynamics, let's define what a system is. So, a system is a part of the universe in which the thermodynamic observations are made. So, dito nagkakaroon ng reactions sa system. Meanwhile, in the surroundings, everything else in the universe other than the system. So, hindi siya part ng reaction. And the universe constitutes the system and surroundings. That's why the system plus the surroundings is equal to the universe. So in thermodynamics, guys, concerned tayo in the processes occurring in various systems. And these are the types of systems: open, closed, and isolated systems. Okay? So we can describe these types of systems based on the energy and matter they transfer. First, for an open system, energy and matter can be both transferred from the system to the surroundings. Okay? So for example, meron kang zinc na nag-react with HCl in an open beaker. That is what we call an open system. Kasi may lumalabas at may papasok na energy and matter. Okay? And then next, we have the closed system. So in closed systems, guys, okay, energy transfer is allowed, but matter transfer is not allowed. So for example, a closed system is a gas in a cylinder with a piston. So kung may gas ka dyan, guys, sa inyong cylinder, okay, that is what we call a closed system. It allows the transfer of energy, gaya ng heat, pero hindi niya ina-allow yung transfer ng matter. Okay? So, lastly, we have what we call the unisolated system. In an isolated system, pinagbabawalan niya ang transfer ng energy and matter. Okay? An example nito is a boiling water in a thermos flask. Okay? So, beyond these classifications, guys, systems can also be described based on how they transfer heat. So, meron tayong tinatawag na adiabatic system where no heat passes into or out from the system to the surroundings. So, pag sinabi naman natin asentropic systems, guys, okay, makinig, there is no heat transfer and entropy change. So, no heat transfer, no entropy change. Okay? Tapos sa polytropic naman, meron kang heat transfer na nangyayari between system and the surroundings. So, don't worry guys, i-discuss pa natin further ang polytropic and isentropic systems. Okay? Pero guys, usually in physical chemistry, we commonly observe closed and isolated systems. Okay? I hope that's clear. Now let's proceed to boundaries. So we have what we call real boundaries and imaginary boundaries. So for example, here we have kape na nasa, or let's say, tsaa. Sige, tsaa na lang. Tsaa na nasa teacup. Okay? And it is defined as the system, yung kape na yan. And everything else outside of it is surroundings. So yung wall ng container nito, which separates the system and the surroundings, di ba? It exists in reality. Nakikita natin siya. It exists. So this is what we call our real boundary. However, when we say there's a small portion of the tea, so for example, nandito siya. Okay? Kunwari, yan yung system natin. So, yung boundaries ng system na iyan are imaginary. Okay? Kasi hindi naman sila nag-exist in reality. On the other hand, flexible boundaries will allow pressure volume work to be done or by the system. Again, in a flexible boundary, pwede ka magkaroon ng pressure volume work. Whereas in rigid boundaries, for example here, kita ditong gas na to, rigid boundaries are inflexible. Hence, they will prevent any pressure volume work to be done or by the system. Okay? And then we have what we call adiabatic boundary. Again, an adiabatic boundary does not allow the transfer of heat. Okay? So, example nito is yung wall ng thermos flask. It is an adiabatic boundary because it does not permit the transfer of heat. Meanwhile, a diathermal boundary, as shown in case 2, okay, it allows the exchange of heat between the system and the surroundings. Okay? For example, yung container ng mug na to. I hope that's clear, guys. Now, in thermodynamics, guys, we have to study state functions and path functions. So example of state functions, guys, is temperature, volume, internal energy, entropy, enthalpy, Gibbs free energy, etc. But when we say path functions, that includes work and heat. So ma'am, anong differences nila? So guys, pag sinabi nating state function, okay, it only depends on the initial and final states. Okay? Okay? So, yung change, kumari, as shown in this figure, di ba nakikita natin na nag-expand or nag-compress ang syringe, right? It undergoes expansion and compression. nagkakaroon siya ng what? Change in volume. Now, for state functions, the change in volume will depend only on the initial and the final volumes. Okay? So, the change in volume will not depend on how we press the syringe or the path it took para mag-press ng syringe. Okay, I hope that's clear. Again, it only depends on the initial and final states. Whereas, kapag path function, tingnan niyo yung figure sa right. Okay? Here, the work done by the athletes habang tumatakbo sila around the track will depend on the path followed by them. Okay? So, for example, yung athlete, itong athlete na gusto niya mag-choose ng another path. Okay? Or that is, mag-change yung trajectory niya. Then, yung work done ng athlete na to compared sa mga athletes na ito, okay, during running, will also change. Again, pag nag-iba to ng path, then mag-iiba yung work done niya habang tumatakbo siya compared sa mga athletes na ito. Okay? This shows that work and heat is a path function because it depends on the path it took in order to reach a certain state. Okay? I hope it's clear, guys. Ayan. So here in this figure, ayan, nasa manual niyo rin yan, it shows the internal energy, delta U, or U, as a state function. So the internal energy in the initial, ito, and the final states is still the same, di ba? Through different paths. O tingnan nyo, same lang pa rin yung initial and final state nyo. Despite the fact na may different paths ka. That is, meron kang different heat and work values. O tingnan nyo guys, dito sa leftmost figure, we see that heat lang ang meron siya with this certain value, but it still reaches a certain final state. Whereas dito sa gitnang scenario, meron tayong onting work is less than 0, tapos meron tayong different value for heat. But even after that, same pa rin ang final state nito, yung nasa gitna sa final state na nasa left. Okay? And that is why internal energy is a state function. Okay? Now, let's review the various thermodynamic processes na ulit-ulitin natin i-discuss throughout thermodynamics. So first, we have isothermal. So when we say isothermal, guys, the temperature is constant, meaning the change in T or dT is equals to 0. Ang example nito, guys, is the slow or the infinitesimal expansion or compression of gas in a heat bath. So dahil sobrang slow niyan, guys, okay, temperature will be constant. Next, we have what we call adiabatic. So in adiabatic systems or adiabatic processes, no heat can flow into or out of system. So the change in Q, which is heat, is equals to 0. An example of this is the rapid expansion of gas in an insulated container. O insulated container, meaning walang lumalabas na heat to the surroundings. Next, sa isobaric processes naman, pressure is constant. So the change in P dT is equals to 0. An example of this is boiling water at constant atmospheric pressure. Lastly, we have isochoric. So here, volume is constant, dV is equals to 0. And ang example natin ito, guys, is the heating of a gas in a rigid and sealed container. Yeah. So here, oh guys, any guess kung ano ang type of thermodynamic process na ito? Any guess, guys? Yeah, so this is what we call an isothermal process. Here, during the melting of ice, so kita nyo, nagme-melt yung ice, diba? The thermometer reading will remain constant throughout the process, meaning constant ang iyong temperature. Okay? Next, we have this process called the isobaric process. Okay? Here we see, guys, a PV graph. So this is P. This is V. Okay? So as you can see, guys, constant kasi ang iyong pressure, right? In isobaric process. That's why yung graph mo ganito. For an isobaric process. Again, yung PV graph na isobaric process is this. So in an isobaric process, every process happening in a system which is exposed to the atmosphere is an isobaric process because the atmospheric pressure will remain constant. Kaya guys, kapag nagluluto tayo inside an open utensil na exposed sa atmosphere, so for example, ito exposed sa atmosphere, isobaric process yan. Okay? Kasi constant ang ating atmospheric pressure. Next, we have what we call an isochoric process. So again, this involves a constant volume process. So again, this is your PV graph. And we know that volume is constant. Kaya ang kanyang graph ay ganito. Straight vertical line. So, an isochoric process is a thermodynamic process in which the volume will remain constant throughout the process. Thus, in an isochoric process, meron lang tayong delta V, change in V, which is equal to 0. Okay? I hope it's clear. But don't worry guys, marami pa tayong examples yan pag dumating na tayo sa mga laws of thermodynamics. Now, before we discuss the first law of thermodynamics, let's discuss the zeroth law of thermodynamics. Sinasabi lang ng zeroth law na if body A is in thermal equilibrium with body B, meaning same temperature, and B is in thermal equilibrium with body C, meaning same temperature, then body A is also in thermal equilibrium with C. Okay? Meaning ito, ang mga three bodies sa ito all have the same temperature and walang net heat na flow between the three of them. Okay? In-establish lang guys ng zeroth law that temperature is measurable and consistent siya na thermodynamic property. And basis din ito for reading and using thermometers. Okay? So, with that, did you know the zeroth law is the reason thermometers work? So, guys, when the thermometer touches your skin, okay, comes in contact with your skin, and reaches the same temperature as your skin or as your body, it quote-unquote, knows your temp without guessing. So, ang fun twist nito, guys, dito sa zeroth law na to, actually, na-discover lang siya after the first, second, and third laws. Okay? So, last na si zeroth law. Pero sa sobrang fundamental niya kasi, okay, ginawa na lang siyang zeroth law. Okay? So, that is your zeroth law. Now, let's proceed to first law of thermodynamics. So, in this lesson, we will discuss work, heat, internal energy, heat transactions in calorimetry, and enthalpy. So, guys, unahin natin discuss muna yung work and heat, which constitutes the internal energy of a system. Okay? So, recap lang, the first law governs that the internal energy, delta U, of an isolated system is constant. Okay? But, it may transform from one state to another state. Yun yung sinasabi ng first law. Okay? So, bakit nagkakaroon ka ng energy change or ng change from one state to another? Okay? Despite the internal energy being constant. That is because of the transfer of heat to and from the system and the work, W, done by or done on the system. Okay? So first, let's discuss work. So work is a transfer of energy from one mechanical system to another. So nangyayari ito when a force acts over a distance, typically against an opposing force. So again, it is done when a force acts over distance, tapos it is done against an opposing force. So may kalaban siyang force. So ang units, guys, ng work is in joules. Ang basic sign conventions natin for work is for work being done on the system. So kunwari, yung surroundings, magagawa siya ng work on the system, then work is positive. Pero pag work is being done by the system, for example, in expansion, then the sign convention or the sign of work is negative. Okay? So explain natin. So example, here we have this figure. Now, when you exert pressure here sa piston na ito, okay? Again, pag nag-insert ka ng pressure dyan, let's say PX, external pressure, ang container na ito, magkakaroon ka ng change in volume. Right? O, kita nyo guys, di ba kasi nag-expand siya, so meron kang change in volume from a smaller volume to a bigger volume kasi kinokontrol mo or nag-exert ka ng pressure sa piston mo. Okay? So, multiplying the external pressure times the change in volume, we get the work done. So, ito ang ating basic formula for work. So, guys, recap lang natin, when work is being done on the system, meaning so sa system ginagawa yung work, okay, positive ang W, and the process is compression. But when the work is being done by the system, meaning si system ang gumagawa ng work, the W is negative. So, ang nangyayari dyan, the process is usually expansion. Okay? Now, how do we differentiate reversible work and irreversible work? Okay? So, pag sinabi natin reversible work, guys, makinig ha. Kunwari, we have here PX. Or let's say this is PX. Or P. Okay? Pag nag-add ka ng pressure dyan, meaning pag pinupush down mo ito, okay, dapat sobrang dahan-dahan lang, infinitesimal ang pag-change ng pressure. Dahan-dahan lang ang pag-add ng pressure. Okay? That occurs for reversible work. Okay? So, pag sinabi natin infinitesimal, meaning sobrang liit. Meaning, dahan-dahan ini-exert ang pressure, hindi pabigla-bigla. And dahil dito guys, dahil sobrang bagal yan, dahil infinitesimal ang pag-exert ng pressure, okay, nagkakaroon ng time ang gas. Okay, let's say ito yung pressure na to. Ito yung PX mo. So, yung gas guys, nagkakaroon siya ng time in order to oppose the pressure from the external pressure. Okay? Again, dahil sobrang bagal mong nag-exert ng external constant pressure, ng external pressure, ito sa taas, then, si gas, may time siya na labanan ang pressure na external na ito. Okay? So, in this case, pataas naman ang pressure ng gas. Si PX naman, external pressure mo, pababa. O, baba, pataas. And that is what we call the reversible work. Okay? What about irreversible work? So, when we say irreversible work, bigla ang expand and compress. Rapid expansion and compression. Di ba, ganyan din tayo. Pag binibigla-bigla tayo, di na tayo makalaban. Charot na. Okay ba? Pero anyway, yun yung point ng irreversible work. It's because it is being done rapidly. Okay? Dahil dyan, si gas, hindi na siya makaka-exert ng pressure in order to reverse the pressure being exerted by the piston. Okay? That's why that is the difference between reversible and irreversible work. Okay? So, here we have work due to expansion. So, these are graphs explaining work due to expansion. Anong observation natin sa graphs na to, guys? So, reversible work is actually bigger than irreversible work, right? So, for expansion, we can say that reversible work is the maximum work obtainable. Kaya, WREF is equal to Wmax. Okay? O guys, bakit kaya ganun? Kasi nga, di ba, sobrang bagal, infinite infinitesimal yung change in pressure. Okay? Kaya yung work na nagkakaroon, yung work na na-exert is bigger compared to irreversible work. Irreversible work kasi guys, rapid kasi yung change or rapid yung work na nangyayari. Kaya mas maliit siya. Okay? Now, how about for compression? For compression naman guys, mas maliit naman ang reversible work than irreversible work. So, for compression, WREV is the minimum work obtainable for compression. Okay? So this table summarizes the differences between reversible and irreversible work. So again, reversible work occurs very slowly and the system stays in balance. So yun yung important guys, di ba? Dahil sa sobrang bagal ng pag-exert ng external pressure, nalalabanan siya ng pressure ng gas. That's why very slow ang reversible work. And as a result, in balance ang ating system. Whereas in irreversible work, it occurs faster, meaning the system is out of balance. Okay? In terms of reversibility, again, reversible work is reversible. Pero si irreversible, hindi. Ang work output naman, again, reversible work produces the maximum work with no energy wasted. Meanwhile, irreversible work produces less work due to energy loss. Now, the energy loss is because, again, rapid yung work na binibigay ng irreversible work. Okay, that's why there is a loss in energy. Lastly, for restoration, for reversible work, the system and surroundings can return to initial state. Diba? Kasi reversible siya. Meanwhile, for irreversible work, it cannot return fully without affecting the surroundings. Ayan. So in thermodynamics, guys, we consider expansion work, which involves the work done in the expansion or compression of a gas. So here on the left, we see the expansion of a gas. And here on the right, we see the compression of a gas. Okay? Ayan. So again, this is our equation for work. Work is equal to negative Px delta V, where Px is the external pressure being exerted on the piston. Okay? Okay. So actually, guys, there are 3 types of work, as you can see here. So first, we have free expansion. So in free expansion, guys, ang example natin dito is for example, a gas na nag-expand into a vacuum. Again, a gas expanding into a vacuum. Walang naghihinder sa expansion ng gas na yan. That's why external pressure is equal to 0. Kasi wala ka namang external pressure na kumakalaban sa expansion na yan. Okay? And as a consequence of that, solving using this equation, we get work is equals to 0. Walang work done kapag free expansion. Okay? So for example, another example, guys, expansion against a constant external pressure Px. So here naman, guys, okay, wait lang. Okay, gas, dito sa figure na to, a piston pushes on a gas. Okay? Dito sa compression. Sa expansion naman, we see that gas pushes a piston with a constant weight on it. Okay? And usually, guys, nangyayari ito sa lab, di ba? Sa lab, di ba yung mga chemical reaction sa lab, kapag nag-expand ang gas, ang lumalaban sa kanya ay ang atmospheric pressure. Okay? So parang ganun yung idea ng constant external pressure. So for example, atmospheric pressure acts like the external pressure. Okay? So in this case, guys, your external pressure is constant. Okay? And when your external pressure is constant, solving for W, we get W is equal to negative Px, external pressure, V2 minus V1. So we got this equation from this. Okay? So dV is just the what? Change in volume. So from the final volume, so V2, final volume minus initial volume. Okay? And lastly, here we have what we call isothermal reversible work. Okay? Oh, ma'am, ano naman yan? Okay. So, ang magandang example nito, guys, is ideal gas slowly expanding in a heat bath. Okay? So, for example, guys, yung gas sa isang piston cylinder device, kunwari yung mga nandito, nilagay mo siya sa thermal bath to maintain constant temperature. Tapos, yung piston ng mga ito, i-adjust siya infinitesimally slowly to allow the gas to expand reversibly and isothermally. Okay? So, ano nangyayari? Since temperature is constant and the expansion is done reversibly, the system stays near equilibrium at every step. Okay? With that, the external pressure is just the gas pressure. Okay? And what is the pressure of a gas, guys? Ano kaya yan? So, we know from our ideal gas law, ayan, right? So, isa-solve lang, isa-substitute lang natin si pressure in terms of nRT over V. Kaya yung magiging formula for isothermal reversible work is equal to negative nRT over V, dV. Ito. Okay? And then getting the integral of this, ano nga guys ang derivative ng dV over V? Sorry, ng integral ng dV over V? It's ln V, right? Kaya siya naging W is equal to negative nRT ln V2 over V1. Okay? I hope that's clear, guys. So let's proceed. Now, let's answer this sample problem. So, An ideal gas sample of 52 moles is compressed isothermally and reversibly at 260 Kelvin, reducing its volume to one-third of its original value. Determine the work done during this process. So guys, we have here an isothermal reversible compression process. Therefore, ang gagamitin natin na formula ay W is equal to negative nRT ln V2 over V1. So guys ha, yung mga formulas natin on work, make sure na i-memorize na natin yan, okay? Very index cardable ang mga equations na yan, okay? Again, they are very important to memorize. So, very straightforward lang pagsagot nito kasi given naman lahat ng variables. So, solving for W, we get negative 52 moles times R, the universal gas constant, which is 8.314 J over mole K, times 260 Kelvin times ln one-third. So guys, one-third because, okay, nag-reduce daw ang original volume to one-third. So meaning yung final volume mo is just one-third of the initial value. Okay, that's why one-third ito. Solving, we get work is equal to 1.23 times 10 to the power of 5 joules. Diba? Very easy. Next question. What is the work associated when 1 mole of iron reacts with 1 mole of HCl at room temperature inside an isolated vessel? So sabi dito guys, meron tayong isolated vessel. Okay? Here, the change in volume is equals to 0 because it's an isolated vessel, meaning it is a closed rigid system na walang pumapasok na matter or energy sa kanya. Okay? So yung gas din guys, hindi rin siya makaka-expand beyond the vessel. Therefore, delta V is equals to 0. Again, in an isolated rigid container, there is no work done because the gas has nowhere to expand. Hindi siya mag-expand. That's why delta V is equals to 0. So solving using this general equation for work is equal to negative P delta V. We get W is equal to negative P times 0 is equals to 0 joules. Therefore, there is no work done when 1 mole of iron reacts with 1 mole of HCl in an isolated vessel at room temperature because the reaction occurs in a closed rigid system where the gas, okay, cannot expand. Okay? And recall guys, di ba? Iron, Fe, plus a strong acid, let's say HCl, creates what, guys? H2 gas. Okay? Ang H2 gas na ito, mag-expand lang, nasa loob lang vessel lang siya, guys. Okay? Hindi siya mag-expand. That's why the delta V or change in V is equals to 0. Now let's proceed to heat. So heat is the energy transferred when a temperature difference occurs between the system and the surroundings. So here we have what we call exothermic processes and endothermic processes. So in an exothermic process, the sign convention of heat is negative. For endothermic, it's positive. Okay? When we say exothermic process, it is the heat released by the system to the surroundings. Again, heat released. Pag endothermic naman, it is the heat absorbed by the system from the surroundings. Ang example ng exothermic processes ay freezing water, nuclear fission, and mixing water with strong acid. These are all exothermic processes. So endothermic processes, examples include water vaporization. So in water vaporization, water absorbs heat para maging water vapor siya. And another example is the production of sugar via photosynthesis. So guys, how is heat being transferred? It is through conduction, convection, and radiation. Recall guys, conduction refers to the direct contact between two bodies for heat to be transferred. Convection naman is the heat transfer through fluid, for example, from hot liquid to cold liquid. So pwede rin through air, okay? And lastly, radiation. So when heat is being radiated. Ito guys, this will be discussed later, pero tandaan, heat at constant volume, pag nasa subscript siya guys, meaning constant yan, okay? Heat at constant volume is just equal to the change in internal energy. Meanwhile, Q, the heat at constant pressure, is just enthalpy. Ayan, okay? Which we will discuss further later. So, pero tandaan niyo lang yan, okay? Now let's proceed to internal energy. So the internal energy of a system, delta U, or it can also be delta E in some references. It is the sum of all possible types of energy found in a system. So it is the sum of the kinetic energy and potential energy of all particles. So guys, tandaan ha, ang internal energy delta U, it can also be delta E. Kasi in some references, delta E ang tawag nila sa internal energy. So kapag sa board exam guys, kung lumitaw sa delta E, baka ma-confuse kayo, okay? So meaning yan is internal energy. So again, internal energy is the total of Ke plus Pe. So again, the kinetic energy of an individual molecule includes contributions due to its rotation and vibration, as well as its translational energy. Meanwhile, yung potential energy naman ng particles is due to the intramolecular interactions or intermolecular interactions. Okay? And with that, since na-discuss natin si work, si heat, and si internal energy, we can now define the first law of thermodynamics. So the first law of thermodynamics states that the energy can neither be created nor destroyed, pero pwede siya mag-transform from one form to another. Thus, the total energy of the universe remains constant. So guys, analogous lang ang first law of thermodynamics to the law of conservation of energy. So this is the first law of thermodynamics. This is the definition. So the internal energy of a system, delta U, is just equal to the heat Q transferred to a system plus W, which is the work done on the system. Okay? So for an open system, guys, internal energy is equal to Q plus work plus the sum of the energy being carried by matter. So ito guys, yung sum of the energy being carried by matter. Tapos, sa closed systems naman, delta U is just equal to Q plus W. Okay? Because we have energy transfer in closed systems. Lastly, for isolated systems, delta U is equal to 0. And there is no energy or matter transfer for isolated systems. That's why delta U is equal to 0. So let's describe work, heat, and the internal energy using various processes. Okay? So first, what if gas in a cylinder with a piston here undergoes compression and heating? So nangyayaring compression, guys, when the piston pushes on the cylinder. Okay? At the same time, hiniheat ang cylinder. Okay? So anong nangyayari? Okay? So guys, di ba yung gas, na hiniheat siya, and at the same time, yung weight above the piston is steadily increasing kasi nagpo-push siya towards the cylinder. Okay? So even after a rise in the internal pressure ng gas, so meron kang internal pressure dito, dahil sa heating, so mag-increase din yung P niyan. Despite that, guys, yung weight kasi ng piston na ito, constantly bumibigat. Kaya si gas na mas lalo siyang nako-compress. That's why the system surroundings, okay, perform the compression work. Okay? And with that, since work is being done on the system, work is positive. And since the system is being heated, Q is positive. Since delta U is equal to Q plus W, then since Q is positive, W is positive, then the internal energy delta U is also positive. Next scenario, here we have expansion of a gas and heating. So here, guys, yung gas nag-expand siya. Okay? Again, yung gas nag-expand siya. So work is being done by the system because the gas is expanding. Therefore, work is negative. Next, Q is positive because heating is being done on the system. So Q is positive. Tapos, ang sign ni delta U will depend on the magnitudes of Q and W. Okay? Since ito negative, since ito positive. Pero depende pa rin yan, guys, kung ano ang magnitude ni Q and W. Okay? Next scenario, here we have compression and cooling. So as the gas inside the cylinder, it is being cooled using ice bath. Tapos, yung weight above the piston is steadily increasing. So work is being done on the system. That's why work is positive. And then, may cooling na nagaganap. So Q is negative. Therefore, delta U will either be positive or negative depending on the magnitude of Q and W. Okay? Next, for expansion and cooling naman, here we see a gas expanding as it is being cooled. Okay? So work is being done by the system because the gas, which is the system, is expanding. Therefore, work is negative. Then may cooling nagaganap, so Q is negative. So, solving, since Q is negative and work is negative, then meaning the internal energy delta U is also negative. With that, let's try to solve this problem. A motor produces mechanical work of 900 kilojoules a minute. While doing so, 120 kilojoules of heat is released by its exhaust. Okay? What is the internal energy change delta U per second? So guys, dapat yung units natin for this problem is what? Kilojoules per second. Para ang makuha natin na internal energy change na value is in kilojoules per second. So solving for Q, okay, we get 120 kilojoules of heat released. Guys, pag sinabi 120 kilojoules of heat release, ang magnitude yan is 120 kilojoules. Tapos, yung 60 seconds na ito, guys, galing to sa statement na a motor produces mechanical work of 900 kilojoules a minute. Okay? Because yung motor, tama naman, it produces work per minute of 900 kilojoules. That's why may 60 seconds dito. Okay? Solving, we get Q is equal to negative 2 kilojoules per second. Next, we solve for work. So work is given also, that is negative 900 kilojoules. O ma'am, bakit negative? Because, guys, yung motor nyo is your system. Work is being done by the system. That's why the sign convention for work is negative. Again, your motor is the system. Siya yung nagproduce ng work. That's why negative 900 kilojoules. And given tayo na ng unit na kilojoules a minute, that's why I put 1 minute here. Then kinonvert ko lang 2 seconds. So we get the value, work is equal to negative 15 kilojoules per second. So now we can finally solve for the change in internal energy in terms of kilojoules per second. So delta U is equal to Q plus W. Delta U is equal to negative 2 kilojoules per second minus 15 kilojoules per second. We get negative 17 kilojoules per second. Okay? So that is your internal energy change per second. Next example. A gas sample does 150 joules of work and at the same time releases 90 joules of internal energy. How much heat is absorbed or released by the gas? Okay? So guys, pause nyo muna and try to answer. Okay guys, now let's answer. So, given tayo ng value for the internal energy which is negative 90 joules. Ulit, negative siya because 90 joules of internal energy ang ni-release. The keyword is release. That's why the sign of the delta U is negative. And then sabi dito, a gas sample does 150 joules of work. So ang system natin dito, guys, is again yung system. So yung system natin dito, guys, is yung gas sample. So the work is being done by the system. So work is equal to negative 150 joules. Solving,
for Q, kasi yun yung hinahanap natin, how much heat is absorbed or released by the gas, using this equation for the first law of thermodynamics, let's transpose to get Q. Okay? Q is equal to delta U minus W. So Q is equal to negative 90 joules, which is your internal energy, minus negative 150 joules. That's just negative 90 plus 150 joules equal to 60 joules. Therefore, 60 joules of heat is absorbed by the gas. Okay? Now, let's proceed to the partial derivatives of delta U. So guys, my differential form, see, change in internal energy. My differential form ang ating first law. And this shows us that the internal energy depends on number one, the temperature, and number two, the volume. So this is the differential form. You have to memorize it. du is equal to the partial derivative of utv dt plus uvt dv. Again, internal energy change is dependent on the change in temperature and the change in volume. Okay. So let's describe these partial derivatives. Okay. So first, we have utv. Okay. Ayan. So, ang partial derivative na utv corresponds to the heat capacity at constant volume cv. And CV refers to the amount of heat needed to increase the temperature of one mole substance to 1 degree Celsius at constant volume. Okay? So, UTV is just equal to CV. Another term, we have UVT, which is dependent on volume. Okay? So, UVT is just equivalent, or it corresponds to the internal pressure pi T. So, pi T, internal pressure, describes how the internal energy transforms as the system's volume expands or contracts at constant temperature. Okay? Again, we describe the internal pressure, how the internal energy transforms as the system's volume expands or contracts. Okay? And it also indicates IMFA strength, and its value is equal to 0 for ideal gases. Tandaan to guys ha, for ideal gases, pi T is equal to 0. Therefore, we can rewrite the differential form of the first law in this way. du is equal to CV dt plus pi T dt. Okay? So guys, dapat gamitin nyo ito palagi kapag nag-solve ng questions on internal energy, lalo na pag may derivations. Okay? So UTV is just equal to CV and UVT is just equal to pi T. Usually guys, in calculations, kinakancel na itong pi T dV. Bakit? Because again, pi T is equals to 0 for ideal gases. And usually in thermodynamics, we solve for the internal energy, heat, work, etc. of ideal gases. Okay? Kaya usually kinakancel out na yung pi T dV. Yeah. With that, here are the various forms of the first law. Yan, ang dami, di ba? Pero don't worry, guys, okay? Isa-isahin natin yan. So first, for an isothermal process, okay, tandaan, temperature is constant. When temperature is constant, guys, okay, di ba, yung delta U nyo is, yung du nyo is equal to CV dt plus pi T dV for an ideal gas. Okay, take note, guys, all of these equations are only applicable to ideal gases. Okay? Again, lahat nito ay applicable to ideal gases. Okay? So, usually na-cancel out na to, right? And we know that in isothermal processes, temperature is constant. That's why dt is equal to 0. So du is just equal to 0. Okay? And with that in mind, we can just express work being not equal to 0, and then Q is just equal to the negative of work. Because based on the first law, okay, 0 is equal to Q plus W, because again, delta U is equal to 0. Next, for an isochoric process, here we have a constant ang volume. So change in volume is equal to 0. Okay, so here guys, ayan, di ba si work is equal to negative P delta V. So when you rewrite the first law equation, U, Q plus W, tapos i-rewrite siya to delta U, Q minus P delta V, syempre, makakancel na to guys. Because again, in isochoric processes, delta V is equal to 0. That's why delta U is just equal to Q, as you can see here. And work is equal to 0 because, again, work is equal to negative P delta V. Since delta V is equal to 0, then work is equal to 0. Okay? Next, for isobaric processes naman, guys, we have constant P. So, ang internal energy is just the usual delta U is equal to Q plus W. And then the work is equal to negative P delta V. So guys, important ang equation na ito for isobaric processes because constant ang pressure. Meaning, ang gagamitin natin na work equation for isobaric processes should be work is equal to negative P delta V because pressure is constant. Okay, so kailangan nyo siyang i-take into account. Now, Q would be equal to delta U plus P delta V. And then the first law is equal to delta U is equal to Q minus P delta V. Okay? Lastly, for adiabatic processes, tandaan, no heat can enter or go out of the system. So, ang mangyayari guys, Q is equal to 0. And dahil dyan, since Q is equal to 0, 0 plus W. So we can say that delta U, internal energy, is just equal to 0. As you can see here. Now, basic qualitative formulas lang to guys. So ito actually ang quantitative formulas natin na applicable to ideal gases. Again, all of these are applicable to ideal gases. Okay, so unahin natin si isothermal. Guys, we know, based on our work, a discussion kanina, work is equal to negative nRT ln V2 over V1 due to the reversible isothermal work. Diba? Again, pag reversible, infinitesimal yung change in volume. Kaya ganito yung equation mo. Okay? Next, since we know that delta U is equal to 0, then Q is just equal to the negative of work, which is Q is equal to negative nRT ln V2 over V1, diba? Because again, Q is just equal to negative work. Next, for isochoric processes naman, we know that work is equal to 0. And we know from the equation, diba, du is equal to CV dt plus pi t dv. Automatic wala na to, diba? So yung du nyo, or yung delta U nyo, is just equal to NCV dt, which is just this one. Kapag in-integrate nyo to, makukuha nyo ang equation na ito. Okay? And that is the equation for internal energy. Now, since delta U is just equal to Q, then Q is just equal to NCV delta T. Okay? Memorize nyo to, guys, okay? Lastly, for isobaric processes naman, guys, it is more complex. So again, work is equal to negative P delta V. Yung internal energy naman niya is still delta U is equal to NCV delta T. Bakit? Because again, dahil dito sa equation na to. Pi T dV. So maka-cancel ito because it's an ideal gas. Tapos du is just equal to CV dt. When you integrate this, you get this answer. Okay? And then Q is equal to NCP delta T. So later we will see the derivation of that. Lastly, for adiabatic processes, again, Q is equals to 0. Okay? Because it is an adiabatic process. And dahil dyan, also, delta U is just equal to NCV delta T. So that is because of this equation again. Okay? Na-cancel ito. Therefore, this is your delta U. So work is just equal to NCV delta T. Okay? Or if you want to express this in terms of pressure and volume, please memorize this equation. So work is equal to P1 V1 minus P2 V2 divided by gamma minus 1. So later we will introduce gamma. So gamma is just CP over CP. Okay? Ayan. So hindi ko na ipapakita yung derivation ng work is equal to P1 V1 is equal to minus P2 V2 over gamma minus 1. Guys, ha? Okay? Kasi ang hirap, medyo complex siya. Okay? Hindi na kailangan makita yung derivation. So let's try to solve this sample problem together. A mole of a monatomic gas is expanded reversibly and isothermally at 0 degrees Celsius from 12.8 to 22.4 liters. Calculate the change in internal energy, Q and W. So guys, first, let's solve using this differential form of the internal energy change, which is du is equal to CV dt plus pi t dv. And we know that this is equal to 0 because we have an isothermal reversible expansion, so dt is equal to 0. Then we know that for an ideal gas, pi t dv, pi t is equal to 0. That's why du is equal to 0. Ma'am, hindi naman nakalagay na ideal gas ito. Pero guys, wala din nakalagay na real gas to. Therefore, we assume that in this problem, the gas is ideal. Okay? Now, knowing delta U, we now solve for W. Okay? Because we know the equation for work, which is equal to negative nRT ln V2 over V1. Solving, we get W is equal to negative 1 mole times 8.314 times 273 Kelvin times ln. Final volume, 22.4 liters divided by 12.8 liters. That is equal to negative 1,271 joules. And we know from this relationship, okay, Q is equal to 0, which is internal energy, minus negative 1,271 joules, which is your work. Therefore, Q is equal to 1,271 joules. Okay? Tandaan ha, for an ideal gas, number 1, pi t is equal to 0 for ideal gases. Okay? Next, a mole of a monoatomic gas is expanded isothermally at 0 degrees Celsius from 12.8 to 22.4 liters. Calculate the change in internal energy, Q and W, if the gas is expanded against a constant external pressure equal to the final pressure of gas. So again, we use this equation to get du, which is still equal to 0. And then, guys, how do we get the constant external pressure? Okay, sabi dito, the constant external pressure is just equal to the final pressure of the gas. So let's just find the final pressure of the gas. So that is P2, which is equal to nRT over V2. So this is just using the ideal gas law. Tandaan, ideal gas law, PV is equal to nRT. We are given, guys, the value for V2, right, which is equal to 32.4. So solving for nRT over V2, 1 mole times 8.314 times 273 Kelvin divided by 22.4 liters, which is V2, and then just convert it to meter cubes for you to get the Pascal value, okay, which is in SI units. So solving, we get 1,101,349 Pascal. And then, guys, we solve for work. Kasi alam na natin yung value for P2. So, now that we know the value for the constant external pressure, Px or Px, okay, we solve for work. Work is equal to negative Px delta V, which is equal to W is equal to negative 1,101,349 Pascal times the change in volume. So that's from this 22.4 liters, convert ko lang to meters cubes, minus the initial volume, which is 12.8 liters, which is convert ko lang to meter cubes. To cubic meters. Solving, we get negative 973 joules for work. Now let's solve for Q. Again, guys, yung Q natin is just the negative of work. Therefore, Q is equal to 973 joules. Hope it's clear. Now, here we have some related topics on the first law of thermodynamics. These are alpha, which is your thermal expansion coefficient, and isothermal compressibility, kappa T. So thermal expansion coefficient is defined as the fractional change in volume with temperature at constant pressure. So ito yung formula niya, guys. Memorize this, please. Alpha is equal to 1 over V, VPP. Okay, again, it is the fractional change in volume with temperature at constant pressure. Next, for isothermal compressibility naman, it is the fractional change in volume with pressure at constant temperature, VPT. So the formula is kappa T is equal to negative 1 over V, VPT. Okay? Ang physical meaning ng thermal expansion coefficient ay, it describes how much a substance expands kapag nahiheat siya. Meanwhile, pag isothermal compressibility naman, it describes how compressible a substance is when it is under pressure. Kapag high ang iyong thermal expansion coefficient alpha, then meaning the volume is highly sensitive to temperature changes. Meanwhile, pag high ang value ng isothermal compressibility, then the volume is highly sensitive to pressure changes. Because again, isothermal compressibility is a fractional change in volume with pressure. And then, guys, ang thermal expansion coefficient alpha, it is related to Q because heat, again, di ba, causes volume expansion. And as a result, the system does work. Okay? Para mag-expand yung volume ng system mo. And ang isothermal compressibility naman, related siya to work. Because when you change the pressure, it causes volume change, right? And as a result, work is being done by the system. And how is this connected to the first law? So the thermal expansion coefficient, it is concerned with the expansion with heat, which involves both heat and work. And we know that heat and work is involved in the first law of thermodynamics. Lastly, for isothermal compressibility, compression does work on the system, right? And that changes the internal energy change value, okay? So, ang typical behavior ni thermal expansion coefficient ay, it increases with temperature for gases and most solids or liquids. Meanwhile, ang isothermal compressibility naman, it decreases with pressure, okay? So, usually, isothermal compressibility is small for solids and larger for gases and liquids, okay? Para lang magets natin ang terms na ito. Now, let's proceed with enthalpy.
So, enthalpy, okay, it is a state function that represents the total heat content of a system at constant pressure. So, ang equation for enthalpy, which is this one, okay, it applies to isobaric processes wherein the PV term is more important. The PV term is more important dahil meron kang constant external pressure. Okay? So, the equation for enthalpy is H is equal to U plus PV. Okay? Tandaan to guys, dapat memorize na yan. And then here, again, let's review an isobaric process. Again, the PV graph is a horizontal line where pressure is constant. Okay? Specifically, enthalpy is the heat energy required in order to increase the internal energy and work, PV, okay, to be done by the thermodynamic system at constant pressure. Okay? So, guys, we are interested only in what happens to heat changes or enthalpy changes of the system during reactions or temperature changes. And then we can also express delta H in this way, delta U plus delta NG RT. So later we will derive or we will know how to determine or derive this equation, okay? In general, the enthalpy of a reaction, delta RH, is equal to the summation of the delta H of products minus the delta H of reactants, okay? And later we'll also discuss that. So now, guys, let's watch this video on enthalpy.
Breaking bonds between atoms requires energy. Creating new bonds releases it. The enthalpy of a reaction is equal to the energy required to break the bonds between the reactants, minus the energy released by the formation of new bonds in the products. So, if a reaction releases more energy than it absorbs, the reaction is exothermic, and enthalpy will be negative. Think of this as an amount of heat leaving, or being subtracted from, the reaction. If a reaction absorbs or uses more energy than it releases, the reaction is endothermic, and enthalpy will be positive. Let's look at the enthalpy changes in the combustion of methane. In this reaction, the bonds between the hydrogens and the carbon and the bonds between the oxygens are broken. Breaking these bonds requires energy to be absorbed by the reaction. But then, new bonds form between hydrogen and oxygen, and between carbon and oxygen. For this reaction, the energy released is larger than the energy absorbed. This means combustion has an overall negative enthalpy, and is an exothermic reaction.
Yeah. So that is the basic concept on enthalpy. Ayan. Now, we also have partial derivatives of delta H. So we also have a differential form of the enthalpy equation, H is equal to U plus PV. And this equation shows us that enthalpy is dependent on temperature, dT, and pressure, dT. So the partial derivatives are HTP and HPP. So let's define each of these partial derivatives. So HTP is the heat capacity, corresponds to the heat capacity at constant pressure. Okay? So it refers to the amount of heat required in order to increase the temperature of one mole substance to 1 degree Celsius at constant pressure. Meanwhile, HPT, which is dependent on pressure, corresponds to the isothermal Joule-Thomson coefficient, mu T. So it describes the amount of heat being provided by a gas to prevent a temperature change as pressure is being changed. Okay? So for ideal gases, mu T is also equal to 0. But for real gases, it is dependent on the intermolecular forces present. Okay? So mu T is equal to 0 for ideal gases. Thus, we can write the equation in this way. So dH is equal to Cp dt plus mu T dt. Okay? Memorize this, guys. Dagdag nyo na to sa inyong index cards or flashcards. Okay? Again, dH is equals to Cp dt plus mu T dt. So to add, guys, okay, so usually, ang ginagamit natin sa thermodynamics calculations is yung dH is equals to Cp dt. Okay? So we usually cancel out this term because we usually solve for ideal gases using this equation. Okay? Again, for ideal gases, we cancel out mu T because it's equal to 0. That's why usually we just use dH is equals to Cp dt. Now, ma'am, paano naman kung liquids and solids? Now, pag liquids and solids, guys, the change in pressure is equal to 0. Okay? Kaya ang enthalpy ng liquids and solids are still dH is equals to Cp dt. Okay? Because mostly the enthalpy of liquids and solids comes from the change in temperature and not from pressure. Okay? So here are the various forms of enthalpy. So for isothermal process, delta H is equal to 0. Bakit? Again, dH is equal to Cp dt plus mu T dt. So again, dt is 0 because constant ang temperature for isothermal processes. Then mu T dP cancel out because these equations are applicable for ideal gases. So mu T is equal to 0. That's why delta H is equal to 0. Next, for isochoric naman, delta H is equal to NCP delta T. So later you will see how you'll derive that. For isobaric, that's delta H is equal to NCP delta T. And for adiabatic, that is also delta H is equal to NCP delta T. So guys, kayang-kaya ito i-memorize, di ba? Okay? So huwag kayo masyadong mag-alala sa mga equations na ito. Okay? Kasi if you think about it, kaya natin to i-memorize. Okay? Pero kung hindi, here are some derivations. So I will just go through it, guys. So for isothermal process, how do we get the enthalpy? So again, ito yung differential form. Then again, constant temperature. So 0 plus mu T dP. Then for an ideal gas, mu T is equals to 0. That's why dH is equals to 0. Therefore, enthalpy delta H is equals to 0. Okay. Next, for isochoric process, okay, we assume that volume is constant. Therefore, dV is equals to 0. So work is equal to 0. And from the first law, we know that delta U is equals to Q. And that for ideal gases, delta U is equals to NCV delta T. Now, we use these expressions, tapos ilalagay natin sila sa enthalpy equation. So here, enthalpy delta H is equal to NCV delta T, which is your delta U, plus NR delta T, which is just your, ano kaya yun, guys? Yung work. Okay? So yan yung PV term nyo, di ba? PV term. Ginawa ko siyang NR delta T. So again, that is your PV term. PV NR delta T. Okay? Again, it corresponds to our general equation for enthalpy, which is delta H is equal to delta U plus PV. Okay? P delta V. And now, guys, we can use this relation, okay, to determine Cp. So makinig, guys. Ang gagawin ko, i-add up ko si Cv plus R. Okay? So ilalabas natin si N delta T. Then, we will arise to this equation. Okay? Now, guys, Cv plus R, tandaan to, is just equal to Cp. Again, Cv plus R is equals to Cp. Meaning, guys, Cp minus Cv is just equal to R. So later, i-derive natin paano mangyayari yung Cp minus Cv is equals to R. Okay. Kaya, delta H is equal to NCP delta T. Because I converted the Cv plus R to Cp. Because Cv plus R is just equal to Cp. Okay. Then, for isobaric processes naman, okay, so we know that work is equal to negative P delta V. And we know that from the ideal gas law, delta V is just equal to nRT over P. So, work, which is equal to negative P delta V, is just equal to negative NR delta T, right? Based on the ideal gas law. Knowing that delta U is equal to NCV delta T, so combine lang natin itong NR delta T and itong NCV delta T to get Q. So from the first law, delta U is equal to Q plus W, so Q is equal to delta U minus W. So solving, delta U is equal to NCV delta T plus work, which is equal to negative NR delta T. Okay? Minus work, so ito yun, guys, diba? Ayan. I hope that's clear, guys. Solving, we get Q is equal to NCP delta T. Because again, Cv plus R is equal to Cp. Okay. Similarly, for delta H, we know that the equation is delta U plus P delta V. So, we knowing that delta U is equal to NCV delta T and PV is equal to NR delta T, then we can just isolate again Cv plus R to get Cp. Therefore, delta H is equal to NCP delta T. Lastly, for adiabatic process, we know that adiabatic work is equal to NCV delta T, right? And from the first law for adiabatic, delta U is equal to W because Q is equal to 0. Okay? Now, our enthalpy equation is this. Delta H is equal to NCV delta T, which is your delta U, plus PV, which is your work. Okay? So ito na yun, NR delta T. Again, isolate lang natin CV plus R para makuha nyo si Cp. Thus, delta H is equal to NCP delta T for an adiabatic process. Okay. Now let's try to solve. Number 1, a mole of a monoatomic gas is expanded reversibly and isothermally at 0 degrees Celsius from 12.8 to 22.4 liters. Calculate delta H. So guys, we just simply have to use the equation for enthalpy for isothermal reversible expansion, which is delta H is equal to NCP delta T. Again, guys, you have to memorize the equations. So we know that delta T is equal to 0 because it's an isothermal process. Therefore, delta H is equal to 0. Number 2, a mole of a monatomic gas is expanded isothermally at 0 degrees Celsius from 12.8 to 22.4 liters. Calculate delta H if the gas is expanded against a constant external pressure equal to the final pressure of a gas. So similar to sa ating sample problem kanina, only here we have to find delta H. So guys, tandaan, enthalpy depends only on temperature for an ideal gas, right? Again, sabi nga dito sa equation na to, dH is equal to Cp dt plus mu T dP. Okay? For an ideal gas, 0 to. Okay, so enthalpy depends only on temperature. However, guys, this is an isothermal reversible expansion. Therefore, temperature does not change, so dt is equals to 0. That's why delta H, the enthalpy, is just equal to 0. Okay, I hope that's clear. Oh, now, let's assume that both the land surface near to the sea and water are at the same temperature. Let's say 20 degrees Celsius. Okay, pareha sila na-expose sa sun hanggang 12 noon, ganon. Due to this, the temperature of the land surface has been raised to 40 degrees Celsius. Pero yung temperature of the water is still around 25 degrees Celsius. So we can see that despite being exposed to the same amount of heat, the rise in temperature of land and water is not the same. Clearly, both have shown different sensitivities to heat in regards to temperature, right? So that's because it takes about 78,000 joules of heat to increase the temperature of a kilogram of seawater from 20 to 40 degrees Celsius, whereas it only takes about 15,000 joules for the same mass of sand to increase its temperature from 20 to 40 degrees Celsius. So, anong mapupulot natin dito, guys? Okay? Basically, ang sand and ang water ay may different na heat capacities. Okay? So, heat capacity C is the amount of energy needed to raise the temperature of a system by 1 degree. So, the specific heat capacity is the amount of heat required to change the temperature of 1 gram of substance by 1 degrees Celsius. Okay, so here we have the heat capacity. Okay, so guys, the heat capacity for a given matter depends on its size or quantity. Thus, heat capacity is an extensive property. Specifically, ang units ng heat capacity ay J over K or J over degrees Celsius. Ma'am, bakit interchangeable ang Kelvin and ang delta Celsius sa units ng heat capacity? Oh, bakit guys? Because the units of temperature sa denominator ng heat capacity pertains to the change in temp. Again, change in temp, not temperature. Okay? Again, it pertains to the change in temp. So, it depends on the given problem or the given, let's say kung sa board exam, bibigyan kayo ng, in terms of degrees Celsius, lahat yung temperatures. Oh. So, yung gagamitin nyo ng capacity na units is, yung denominator dapat degrees Celsius din. Okay? Okay? So, both enthalpy, guys, and heat capacity, they're actually dependent on temperature. Since, habang nag-absorb ng heat ang system, the molecules tend to move faster. And this increases the kinetic energy and the temperature of the system. Okay? Now, we have here the specific heat capacity. Again, it is the amount of heat required to change the temperature of 1 gram of substance by 1 degree Celsius. So here, specific heat is C sub S is equal to Q, which is heat, divided by M delta T. Okay, so M is your mass and delta T is your temperature difference. Okay, so di ba guys, sikat to, this is basically just Q is equal to M cap, right? Meanwhile, iba naman ang molar heat capacity. When we say molar heat capacity, it is the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius. Again, this time we have the raising of the temperature of 1 mole of a substance. Okay, specific heat capacity, it is the changing of the temperature of 1 gram of substance. So this is the molar heat capacity. C sub M is equal to Q over N, which is the number of moles times the change in temperature. Okay? So guys, make sure na alam niyo yung differences ng bawat isa. Okay. Now, this summarizes the concepts concerning the heat capacity. So guys, when we say heat capacity at constant volume, tandaan, it's CV is equal to mu UT over UTV, diba? UTV, diba? Base ito sa partial derivatives ng delta U. Again, the heat capacity at constant volume explains how internal energy changes with temperature at constant volume. Again, how internal energy changes with T at constant V. Next, heat capacity at constant pressure, Cp, is equal to HTP. Okay? This describes how enthalpy changes with temperature at constant P. Now, the internal energy change can also be correlated to the heat capacity. Diba? Na-derive natin ito kanina. So, delta U is just equal to the heat at constant volume, which is equal to CV delta T. So, this can also be NCV delta T or NCP delta T, depending, guys, kung may moles yung given problem. So, meaning lang ito, guys, at constant volume, all heat goes into changing internal energy. Pag enthalpy change naman, delta H is equal to the heat at constant pressure, which is equal to NCP delta T. So, at constant pressure, heat goes into both internal energy and expansion work. Oh, diba? Because, again, delta H is equal to delta U plus P delta V. Okay? That's why heat goes into both internal energy and expansion work. Now, let's derive how we can determine the Cp and Cv relation. So first, let's determine the first law of the thermodynamics for ideal gas. So that is dq is equal to du plus pdv. Okay? So, ang ginawa ko lang dito, guys, in-interchange ko lang si q and si du. Okay? So, this is just basically, again, u is equal to q plus w. Pero this time, kinuha ko yung dq, change in q, is equal to du plus pdv. So, itong pdv, guys, is your work. Okay? Now, if heat is supplied at constant volume, meaning dv is equals to 0, therefore, maka-cancel out mo to. Thus, dqv is equal to du. Recall, guys, that the internal energy for ideal gases is dqv is equal to ncv dt. Therefore, du, or the internal energy, is equal to ncv dt. Okay? So, guys, same lang ito sa dito. Delta u is equal to ncv delta t. Okay? Only that, ito, guys, kailangan nyo muna kunin yung integral nila before you can get this. Okay? Now, guys, we know that heat at constant pressure is Qp is equal to ncp dt. Diba? Q is equal to ncp dt, right? Now, we can just combine du from 3, ito, and dq from 4. O, paano? dq, ito yung ncp dt nyo, qp, is equal to delta u plus pdv. Okay? So, again, kinombine ko lang silang dalawa. And ang equation na ito ay galing dito, right? Okay. Now, remember from ideal gas law, PV is equal to nRT. Therefore, PdV is equal to nRDT if we get the derivative. So let's combine 5 and 6. So when we combine that, we change natin si PdV into nRDT. So ncpdt is equal to ncvdt plus nRDT. Oh, with that, guys, pwede na natin makuha yung relations. O, paano? Guys, yung mga dt na to, pwede nyo i-cancel yan. Pakita ko sa inyo. Plus rdt is equal to ncpdt. So ito, cancel, and can also be cancelled. Ang natitira na lang ay si Cp equal to Cv plus R. Transposing, we get Cp minus Cv is equal to R. So guys, memorize nyo lang ang relation na to, Cp minus Cv is equal to R. Okay? Now, the relationship between the heat capacities is generally the heat capacity at constant pressure is greater than the heat capacity at constant volume. So the adiabatic index gamma pertains to the heat capacity ratio. And important ito in determining the behavior of ideal gases upon compression in adiabatic processes. So at any condition, guys, ito daw ang relation ni Cp and Cv. Meaning, ito yung ideal and real condition. So Cp minus Cv is equal to alpha squared Tv divided by kappa. Pero guys, kung may ideal condition ka naman, which is usually nagagamit sa board exam, ito lang naman, Cp bar minus Cv bar is equal to R. Okay? Where gamma, the adiabatic index, or the heat capacity ratio is equal to Cp over Cv. Tandaan to, guys, okay? Now, we can determine the heat capacity values of monoatomic, diatomic, and nonlinear polyatomic gases through these values. Okay? So, dapat i-memorize nyo lang to, guys. Okay? So, for monoatomic, Cp value is 2.5 R. So, pag 2.5 R, meaning 2.5 times 8.314. For Cv, it's 1.5 times 8.314. And it's gamma, Cp over Cv is just 5/3. Okay? For diatomic or linear polyatomic, so for example, we have CO2. Okay? Ang Cp and Cv nila are 3.5 R and 2.5 R respectively, and their gamma is 7/5. For nonlinear polyatomic, for example, H2O, the Cp is 4 R, Cv is 3 R, and the gamma is 4/3. So you can just, actually guys, hindi naman kailangan to i-memorize yung gamma. Pwede na lang kunin yung Cp over Cv. Nito, and ito, ito, and ito. Okay? Again, these are the heat capacity values for monoatomic, diatomic, linear polyatomic, and nonlinear polyatomic ideal gases. Okay? Again, this is only applicable yung table na to for ideal gases. Now, let's answer. Determine the amount of heat required to increase the temperature of 7 moles of each of the following ideal gases by 50 Kelvin. So for helium at constant P, okay, so helium, it is a monoatomic gas. So its Cv is equal to 1.5 R. Solving for the amount of heat required to increase the temperature of 7 moles of each of the following gases by 50K, ang gagamitin natin equation ay Q is equal to N, ano yun guys? N Cv delta T, okay? Or NCP delta T. So here we use Q is equal to NCV delta T. So Q is equal to 7 moles, which is given, times 1.5 R times 50K. We get Q is equal to 4,365 joules. Next, for argon at constant P, so argon is a monoatomic gas. Its heat capacity at constant pressure is equal to 2.5 R. Solving for Q, the heat, 7 mole times 2.5 R times 50 Kelvin. Solving, we get Q is equal to 7,275 joules. Lastly, for nitrogen, it is a diatomic molecule, N2. So Cv is equal to 2.5 R. Okay? Tapos, Q is equal to 7 moles times 2.5 R times 50K. Okay? So again, galing sa heat capacity table ang values na ito. Solving, we get Q is equal to 7,275 joules. Okay? I hope that's clear. Next problem. A system containing 2 moles of an ideal monoatomic gas expands adiabatically and reversibly from a volume of 5 liters and a temperature of 373 Kelvin to a volume of 20 liters. Calculate the internal energy change, enthalpy change, heat, and work. So guys, tandaan lang ito, CV is equal to 1.5 R and CP is equal to 2.5 R for an ideal monoatomic gas. Okay? And then we can just solve for the gamma, which is equal to CP over CV. So that's 2.5 divided by 1.5, that is equal to 5 over 3. Now guys, may introduce ako na bagong equation sa inyo. Okay? Kasi ang hinihingi kasi sa problem na ito, mas complex, okay? Hindi straightforward yung calculations niya. This is concerning a polytropic and adiabatic system. Pag sinabi natin guys na polytropic and adiabatic system, E, P, and T are not constant. Okay? Therefore, we have to use other equations in order to determine other variables. So here guys, we will use this equation. Okay? Please memorize this. T1 V1 to the power of gamma minus 1 is equal to T2 V2 to the power of gamma minus 1. Here guys, kailangan natin makuha ang final temperature T2. Okay? Kasi diba yung ideal monoatomic gas daw, it expanded adiabatically and reversible. Okay? Tapos yung initial temperature niya daw is 373 K. But we don't know its final temperature. Kay volume naman, alam natin ang initial volume and ang final volume. Therefore, we have to find T2. Kasi guys, in this case, hindi naman constant si temperature, right? Hindi naman siya isothermal. That's why we have to find T2. So solving using this equation, T2 is equal to T1 times V1 over V2 to the power of Y minus 1, gamma minus 1. Solving, so substitute lang yung mga given values. 373 Kelvin times 5 liters divided by 20 liters to the power of 5/3 minus 1. So 5/3, ito yung gamma nyo, minus 1. That is equal to 148 Kelvin. So that is your final temperature after the adiabatic expansion of the ideal monoatomic gas. Okay? So now, we can solve for the internal energy change using this equation. O, di ba alam na natin yung equation na ito, relevant to sa adiabatic process. Delta U is equal to NCV delta T. Di ba? So, syempre guys, hindi natin ito masasolve kung hindi natin alam si final temperature or si T2. So, solving, internal energy is equal to 2 moles times 1.5 R, which is your CV, times T2, 148 Kelvin, which is what we solved, minus the initial temperature, which is 373 Kelvin. Solving, we get negative 612 joules. And then we can just do the same for delta H. So again, kailangan natin hanapin kanina si T2 para makuha natin si delta U and delta H. So let's solve for delta H. That is equal to negative 9,354 joules. Now, we can solve for work. Okay? And Q. Through this equation from the first law of thermodynamics. So work is equal to delta U minus Q, which is equal to negative 5,612 joules minus 0 joules. And that is equal to negative 5,612 joules. Now guys, tandaan, this is an adiabatic process. No heat is coming out or going into the system. That's why Q is equal to 0 joules. Diba? Kayang-kaya niyo to guys. Okay? Himay-himayin niyo lang. Again, for adiabatic and polytropic processes, gaya ng example na ito, so pwede niyo itong gawing model example, kailangan yung hanapin yung mga missing variables. So in this case, missing variable natin is yung final temperature. Kaya natin siya kinuha. Tapos, tsaka niyo masasolve yung delta U, delta H, and work. Okay? Now, let's proceed to a related topic in first law of thermodynamics and enthalpy. So that is the Joule-Thomson effect. So guys, let's watch this video first on the Joule-Thomson effect.
Joule-Thomson effect demonstrates that in an adiabatic system, if a gas kept at a high pressure is forced to pass through a porous plug into a low pressure region, it expands and occupies a larger volume, changing its temperature and, as a result, its internal energy. In this adiabatic process, the change in the internal energy of gas must equal the work done on the gas minus the work done by the gas. Rearranging the terms shows that enthalpy is conserved. The change in temperature with pressure at constant enthalpy is defined as the Joule-Thomson coefficient. Using the reciprocity theorem and substituting the heat capacity relation, the Joule-Thomson coefficient is expressed in terms of the partial derivative of enthalpy with pressure. Expressing the partial derivative in terms of entropy and using Maxwell's relation gives the Joule-Thomson coefficient as a function of temperature. A positive coefficient value indicates cooling, while a negative value indicates heating of gas during expansion. For an ideal gas, the Joule-Thomson coefficient is 0, as its temperature remains the same on passing to the low-pressure region.
Ayan. So this is the basic concept on Joule-Thomson effect. Don't worry guys, pagdating natin sa gaseous state na crash course, we will further discuss on the Joule-Thomson effect. But that is the basic concept, okay? So, again, the Joule-Thomson effect shows the rate of temperature change. So the rate of temperature change is equal to the Joule-Thomson coefficient, mu Jt, which is equal to TPH. So this equation shows that as the temperature of the gas varies, okay, with pressure, okay, mu Jt changes, okay? Again, guys, the Joule-Thomson effect shows an isenthalpic expansion, meaning, guys, okay, at constant enthalpy, nangyayari yung change in temperature as pressure changes, okay? So the temperature at which the Joule-Thomson coefficient shifts sign is called the inversion temperature. So that is Ti, inversion temperature, is equal to 2A over RB. Now, table 8 in your manual shows the interpretations of the Joule-Thomson effect. So basically, guys, pag greater than 0 ang Joule-Thomson effect nyo, then the gas cools upon expansion. Pag nag-expand, cool ang gas. And ang P and T nyo yan is lower pressure and lower temperature. Whereas if your mu JT is less than 0, then meaning the gas warms upon expansion. And consequently, lower pressure means higher temperature. Lastly, if mu JT is equals to 0, then there is no temperature change upon expansion. Therefore, there is only a decrease in pressure because of the expansion. However, there is no change in temperature. Okay? I hope it's clear, guys. So, guys, in addition to that, the Joule-Thomson coefficient is 0 for an ideal gas, indicating that there is no temperature change when an ideal gas undergoes a throttling process. Okay? So, the coefficient is negative for real gases at extremely high and extremely low pressures. Okay? Sorry, extremely high and extremely low temperatures. Okay? Now, let's proceed to heat transactions in calorimetry. So, what is calorimetry? Calorimetry measures the transfer of heat as physical and chemical changes occur. Yung calorimeter, siya yung device na ginagamit in measuring heat at specific conditions. There are two common examples of calorimeter, namely the coffee cup calorimeter, which is a constant pressure calorimeter. Okay, and this is its equation. Okay, delta H, change in enthalpy, is equal to negative C cal delta T, where C cal is the calorimeter constant, minus MCP of water delta T. So guys, yung CP dito is the heat capacity of water. Okay, so basically guys, take into account lang yung temperature changes in the calorimeter and in water. Okay. Next, we have bomb calorimeter. So this is a constant volume calorimeter. Okay, and this is the equation. Delta H is equal to delta U plus delta NGRT. So guys, fun fact lang sa coffee cup calorimeter, yung nagamit natin sa lab noon, di ba? Parang dati, pinapagamit sa atin parang styrofoam cup as a coffee cup calorimeter. Actually, scam yun. Inaccurate yun, guys. Kasi may lumalabas pa rin na heat from the styro. Meron talagang equipment called the coffee cup calorimeter. Okay? So again, the coffee cup calorimeter is a simple setup used in the lab to experimentally explain the concepts behind calorimetry. Okay? So basically, yung cup and yung contents ang isolated system. And it ensures that there is no heat transfer between the cup and the surrounding air while measuring the temperature change of a reaction in the system. Now, for a bomb calorimeter, it measures the amount of heat evolved in a combustion reaction. So, ginagamit ito in combustion reaction. So, it is similar to a coffee cup calorimeter where its isolated system consists all contents inside the double-walled jacket of the calorimeter. So, the system consists of the sample, the bomb cell, water, thermometer, and stirrer. So, ginagamit ang device na ito in determining the calorie value or energy content of food, waste materials, and fuel. Okay, again, this is for constant volume reactions. We use the constant volume calorimeter, the bomb calorimeter. Okay, so guys, in the bomb calorimeter, gas is being produced in the bomb cell. So, dapat extremely rigid and therefore constant ang volume within the bomb cell. Okay, hinahayaan ang sample na mag-burn gamit ang ignition wire. Okay, so later you will further learn how a bomb calorimeter works. Okay. So guys, how did we arrive to this equation? Delta H is equal to delta U plus delta NGRT. Oh. Tandaan guys na H is equal to U plus PV, right? So DH is equal to DU plus VDP. Okay? Guys, di ba mababago ang pressure sa loob ng bomb cell kapag may naproproduce kang gas, right? So pressure changes in this case. Kaya may DP ka. However, notice na hindi ako nagsama ng PV term. Example, walang ganito. Because again, the volume must be constant for a bomb calorimeter. So, let's derive this. VDP. Okay? Itong VDP natin, guys, magiging, okay, sulat ko dito. Again, DH is equal to DU plus VDP. Ang VDP ay magiging VD nRT over V. Again, VD nRT over V because P is equal to nRT over V based on our ideal gas law. And here, notice, guys, na you have change in moles. Again, you have change in moles here. That's why, ang magiging equation ay delta H is equal to delta U plus RT delta N. Tapos maglalagay ako guys ng G dito. Maglalagay ako ng G dito to indicate na gases lang ang tinitingnan natin sa combustion reaction. Again, kaya may G dito sa ating moles because this ensures na gases lang tinitingnan natin sa combustion reaction. Kasi, syempre, gases lang ang may contribution sa change in pressure sa bomb cell. Okay, so this equation, guys, is also applicable not only to bomb calorimeter but also to isochoric processes. Okay. Now, let's watch this video to know more about the coffee cup calorimeter.
For a chemical reaction carried out under constant pressure, such as atmospheric pressure, the heat exchanged during the process is measured as the change in enthalpy, delta H. The enthalpy change for the reaction is manifested as a change in temperature, which is measured using a technique called calorimetry. In calorimetry, the reaction is executed in a sealed and calibrated container called a calorimeter. The calorimeter is well insulated and prevents any heat flow between itself and its environment. Thus, heat exchanged between the reactants and products, which constitute the system, and the calorimeter, which is the surroundings, can be accurately calculated by monitoring the subsequent changes in the temperature in the calorimeter. If the reaction is exothermic, heat flows from the system into the surroundings, and the temperature rises. Conversely, if the reaction is endothermic, heat flows from the surroundings into the system, causing the temperature of the calorimeter to fall. A simple coffee cup calorimeter measures change in enthalpy of a reaction occurring in a solution under constant pressure conditions. The calorimeter consists of 2 styrofoam coffee cups nested together and equipped with a thermometer and a stirrer. The calorimeter is closed with a loose-fitting cork lid to maintain conditions of constant pressure that is open to the atmosphere. Suppose 50.0 milliliters each of 1.0 molar aqueous hydrochloric acid and 1.0 molar aqueous potassium hydroxide react within the calorimeter to raise the temperature of the solution by 6.9 degrees Celsius. The heat absorbed by the solution, Q solution, is equal to its specific heat, CS, 4.18 joules per gram degree Celsius, just below that of water, multiplied by its total mass M, 100.0 grams, and the change in temperature. The heat of the solution is 2.9 times 10 to the power of 3 joules, or 2.9 kilojoules. The heat of the reaction, Q reaction, has the same value but with an opposite sign. Because the pressure is constant, the enthalpy change is the same as the heat of the reaction. To find the enthalpy change of the reaction per mole, the enthalpy is divided by the number of moles of hydrochloric acid. The moles of hydrochloric acid are found by multiplying the volume in liters, 0.05 liters, with the molarity, 1 molar. Therefore, negative 2.9 kilojoules divided by 0.050 moles gives negative 58 kilojoules per mole.
Okay, so that is the concept on coffee cup calorimeter. Now let's proceed to bomb calorimeter.
The change in the internal energy of a reaction, delta E, is the sum of both heat Q and work W. While it is simple to measure heat through temperature changes, measuring the pressure-volume type work through changes in volume is inconvenient. For gaseous chemical reactions, if the volume is not allowed to change, then delta V equals 0, and consequently W will be 0. Thus, the internal energy change of the reaction will exactly equal the heat transferred. Under constant volume conditions, the heat transferred in a reaction is measured using a bomb calorimeter. This is different from a coffee cup calorimeter, which measures the heat of a reaction under constant pressure conditions. In a bomb calorimeter, 0.512 grams of naphthalene is placed in a stainless steel bomb. Through an inlet, the ignition coil is placed in contact with the sample. The bomb is then filled with oxygen and immersed in an insulated container filled with a known mass of water. Electrically igniting the reactant initiates the combustion reaction inside the bomb. The heat released is absorbed by the water and the various components of the calorimeter assembly, which all together make up the surroundings. This causes the temperature to rise by 6.42 degrees Celsius. The heat absorbed by the entire calorimeter assembly, Qcal, equals its heat capacity, Ccal, multiplied by the temperature change, delta T. If the experimentally determined value for Ccal is 3.20 kilojoules per degree Celsius, then substituting this, along with the value for delta T, gives the heat of the calorimeter as 20.5 kilojoules. The heat gained by the calorimeter exactly equals the heat released by the reaction. The bomb being sealed, the reaction occurs at constant volume, and the work done is 0. Thus, the heat of the reaction equals its internal energy change, negative 20.5 kilojoules. Dividing this value by the number of moles in 0.512 grams of naphthalene, 3.99 times 10 to the negative 3 moles, gives the change in internal energy per mole of naphthalene, which is negative 5,140 kilojoules per mole.
Okay, now that is the basic concept on bomb calorimeter. Okay, I hope it's clear, guys. I hope clear tayo sa first part ng ating thermodynamics 1. Now, let's proceed to thermochemistry. So, thermochemistry is the study of heat energy transfer during chemical reactions. So, yung reaction medium, guys, and its components, yun yung system. While chemical reactions between the system and the surroundings involve heat transfer. Okay, so for this part of our thermodynamics 1, we will discuss the properties of enthalpy, enthalpies of physical changes, enthalpies of chemical changes, and the variation of enthalpy with temperature. Okay, let's G. So, we know that enthalpy is an extensive property. So, it depends on the amount of substance presence. By following Hess's law, the following properties of enthalpy enables accurate calculation of heat changes in chemical reactions and physical processes. So, first property is that the enthalpies of reactions can be scaled. So, for example, here you have a reaction A plus B forms C products, okay? And you have a delta H. You can scale this whole reaction by multiplying it all to 2. Pag minultiply mo to 2, okay, then dapat multiply mo rin to 2 ang iyong enthalpy change. Next, for reversing the reaction, the sign of the enthalpy of reaction is reversed when the reaction is reversed. So, for example, in this reaction, pag kunwari, ni-reverse mo siya, ito na yung reverse version niya, then you should also reverse the enthalpy change value by putting a negative sign. Lastly, the Hess's law of constant heat summation, it indicates that the standard enthalpy of an overall reaction is the sum of the individual reactions into which the reactions might be subdivided. So basically, yung sum ng individual reactions, for example, ito, and ito, results in the overall reaction ito. And when you combine two equations, guys, syempre, kailangan nyo din i-combine yung respective enthalpy changes nila. Okay? Oh, tingnan natin sa example na ito. When you combine reaction 1 with reaction 2, maka-cancel out lang si D plus E, right? And this results in an overall reaction of A plus B forms C. Tapos, ang value ng delta H nila is the summation of delta H of the first reaction and delta H of the second reaction. Now let's try to answer. What is the standard enthalpy of formation for glucose? Given glucose plus oxygen forms carbon dioxide and water. So in this reaction, guys, okay, try natin i-determine ang standard enthalpy of formation using the properties of enthalpy. Here we are given the enthalpy of combustion for glucose, which is equal to negative 2808 kilojoules per mole. Enthalpy of formation for CO2, which is equal to negative 393.5 kilojoules per mole. And lastly, for the enthalpy of formation for water, that is negative 285.8 kilojoules per mole. So, solving, guys, okay, again, ang hinahanap natin sa sample problem na ito is the standard enthalpy of formation for glucose, which is this one. Okay? Pero ang given sa atin, guys, is the enthalpy of combustion for glucose. Okay? Which is just analogous to the enthalpy of combustion for the reaction. Okay?